A giant volcano has been found near Mars's equator. It was literally hiding in plain sight. It's deeply eroded but active from ancient to recent times. There might even be remnants of glacier ice near its base. That's why this discovery might indicate a promising new location to search for life, as well as a potential destination for future human and robotic exploration. The discovery of a giant volcano and a possible sheet of hidden glacier ice was announced at the 55th Lunar and Planetary Science Conference in Texas. The volcano is located in the eastern part of Mars' Tharsis volcanic province, between Labyrinth of the Night and Valles of Mariner. The formation was actually repeatedly spotted by spacecraft orbiting Mars, but it's so deeply eroded that it was hard to recognize it for what it really was. The structure is still awaiting its official name. At the moment, it's referred to as the Noctis volcano. It reaches a height of 29,600 feet and spans an impressive 280 miles across. Such a giant size indicates that the volcano has been active for a very long time. In its southeastern part, there's a thin recent volcanic deposit, and beneath, glacier ice might still be present. Scientists were examining the geology of the area where they had spotted the remains of a glacier the year before when they realized they were inside a volcano. Several clues gave away the volcanic origin of the eroded structure. For example, the area of the central summit has a few elevated mesas forming an arc. It reaches the highest point and then slopes downhill from the summit. The outer slopes extend out to 140 miles in different directions. The remains of a collapsed volcanic crater that used to host a lava lake are located near the center of the structure. Lava flows and deposits made of volcanic ash, cinders, pumice, and rock fragments ejected during eruptions, as well as hydrated mineral deposits, appear in several spots within the structure. In addition to the volcano, a large area of volcanic deposits within the volcano's perimeter has been found, too. It covers an area of 1,930 square miles and contains loads of low, rounded, elongated, blister-like mounds. Such terrain is believed to be a field of rootless cones, mounds produced by explosive steam venting or steam swelling. It happens when a thick cover of hot volcanic materials happens to rest on a water or ice-rich surface. The Noctis volcano seems to have a long and complicated history of modifications. They might have occurred because of the combination of fracturing and thermal and glacial erosion. Researchers believe the volcano could be a vast shield made of layers of pyroclastic materials, lava, and ice. The latter might have appeared due to snow and glaciers accumulating on the volcano's flanks through time. Eventually, fractures and faults developed in the region, probably due to the uplift of the Tharsis region on which the volcano sits. Lava started to rise through various parts of the volcano. It led to thermal erosion and the removal of huge amounts of hidden ice. Entire sections of the volcano collapsed. Glaciers continued the erosion process, giving the numerous canyons crisscrossing the structure their peculiar shape. If this version is correct, then possible hidden sheets of glacier ice around the volcano might be the remains of the latest glaciation that impacted the Noctis volcano. And still, a lot about the newly discovered formation remains a mystery. It's obvious that it has been active for a long time and started to grow early in Mars's history, but it's unclear when exactly. Even though it erupted even in modern times, it's unknown if it's still volcanically active. Will it erupt again when people begin to colonize the Red Planet? And finally, if it has been active for a very long time, is it possible for the combination of constant warmth and water from ice to allow the site to harbor life?
Imagine a world where the red, barren landscape of Mars is transformed into a lush and verdant garden. A world where water flows freely, carving canyons and creating lakes and oceans. Can we achieve such a world by pouring the Earth's water onto the surface of Mars? And don't rush to say no. Let's explore this possibility. Alright, let's say we could magically transport all of the water on Earth to Mars. This supersized game of water pong would be crazy in both engineering and logistics. So how do we even do that? First of all, we're talking about millions and millions of gallons of water, which is no small feat. We would need some really big tanks to get all this water off the Earth. We would also have to figure out how to launch it all into space. This would require some serious rocket technology, as well as a lot of fuel. We could probably create an entire fleet of spacecraft specifically designed for the task. Just imagine that, a fleet of giant water tankers packed with tons of carefully harvested water, blasting off from Earth's surface and hurtling through space at unimaginable speeds. Wouldn't that be a cool sight? Now, another way. Probably a better one would be to launch a large number of smaller missions over time, each carrying a smaller amount of water until enough of it has been transported to Mars. So, let's say we manage to do all that. What happens next? After we get to Mars, we'd need to distribute this water all across the planet. We could use a network of underground pipes or some special drones to transport the water to different locations. This is just some basic things, and as you can see, we already need a lot of planning and resources. Moreover, a crazy operation like this would require a massive coordinated effort from scientists, engineers, and space agencies all over the world. And let's not forget about the costs. No wonder that scientists don't really consider it a viable plan. But the scale of this operation isn't the only problem. Hypothetically, let's say that we figured all that out and poured the Earth's water on Mars. Now what? Well, believe it or not, it would be almost completely useless. Our main challenge will be the atmosphere and current climate of Mars. Mars is a dry desert with an atmosphere that's only about 1% as thick as Earth's. This means that any water poured onto the surface would quickly evaporate. It would be pretty hard to create a stable environment when the entire lake can go poosh in a matter of seconds. And if the water doesn't evaporate, then, on the contrary, it will turn into ice. Mars' surface temperature is well below freezing. Thin atmosphere only makes things worse. Another challenge is that Mars has a very weak magnetic field, which means it has little protection from the solar wind. Solar wind is a stream of charged particles that are constantly flowing out from the sun. These winds are pretty dangerous. They can strip away any water that's put on the Mars surface. Also, the solar radiation on Mars is much stronger than on Earth. This would make it even more difficult to maintain any liquid water there. And finally, don't forget that we also need to purify this water to remove all the bacteria before drinking it. But let's not give up. If we stay super optimistic, we can still try to solve these problems. Basically, we need to find a way to maintain liquid water in one place for a long time and make sure that it doesn't freeze or evaporate. So how do we do it? There are a few ways we can go about it. Number 1. Insulation. We could wrap all the water containers in insulation materials, like foam for example, or some reflective materials that can help to keep the water from freezing. Number 2. Heating. We could use various heaters and devices to keep the temperatures above freezing, even thermal blankets. Although this would require a lot of energy and would be a difficult task. Number 3. Underground reservoirs. We could dig a large hole and cover it with a transparent material to allow sunlight to pass through. This would help keep the water warm and insulated. Number 4. Salinity. Adding a small amount of salt or other dissolved minerals to water can lower its freezing point. Although we'll need much more salt for things like lakes, and this method isn't the most efficient. And finally, number 5. Building a greenhouse. We could build a greenhouse or some other structure that can trap heat and create a more Earth-like environment. This option is probably the best one. After all, a greenhouse would also help us to grow various plants or other organisms. Yay, life! Alright, great. Let's say we've discovered some way to store water on Mars and keep it there in a liquid, lukewarm state. What now? What impact would this have on Mars? Actually, this would be great. If we were to pour all this water on Mars, it could have drastically changed the climate of this cold, red desert. First of all, we could create a so-called greenhouse effect. It's when gases in a planet's atmosphere trap heat, causing the planet's temperature to rise. And yeah, this is pretty bad for Earth, but for Mars, whose temperatures jump between 70 and negative 200 degrees Fahrenheit, it would be awesome. This could cause the atmosphere to thicken and lead to the melting of the polar ice caps. Wouldn't that be awesome? Mars would begin to gradually turn from a lonely desert into Earth 2.0. It also means that the planet's atmosphere will change. For example, the weather patterns. Clouds could form on Mars, rains would begin to fall. And rains, as we know, transfer water from one region to another, which would mean they could water plants if they appeared on Mars. But all of this is pure speculation. We can't be completely sure what kind of impact pouring water on the Martian surface would have on the planet's climate. Perhaps, to create this greenhouse effect, we would need much more water than what we can transport. But if despite all these challenges, we had succeeded with our mission and made Mars much warmer and moist, could life have been finally born there? Unfortunately, that would still be pretty unlikely. Yes, water is very important for creating life, but that's not all we need. The composition of the Martian soil isn't very conducive to supporting life. The soil is mostly made of minerals called regolith, which are composed mainly of dust, sand, and other materials that aren't very good for plants. Theoretically, we could terraform Mars. Terraforming is a gradual, slow change of the planet so that it becomes suitable for our life, but this would be a very complex, long, and costly process. Oh, and by the way, what would happen to our Earth after all that? We took quite a lot of water, didn't we? From Earth's perspective, transporting water to Mars would require an enormous amount of resources, including energy and different materials. And the amount of water we'd have to spend would be staggering. The loss of such a large amount of water from Earth's own reserves could have a significant impact on our planet, especially in areas where water is already scarce. So basically, this is a really bad idea, no matter how you look at it. Yeah, it may sound interesting, but it's not a viable plan at all. It would require too many resources, too much money, and it wouldn't even be worth it. That's why scientists and space agencies don't consider this idea seriously. Besides, there are many other more realistic and achievable goals in the field of Mars exploration. For example, we can keep studying the planet's geology, atmosphere, and potential for past or present life. These studies would help us to find some resources that could support future human exploration. Overall, we need to answer many more questions about Mars before we even begin to consider colonizing it. So let's keep an eye on scientific news and updates.
The soil beneath your feet is red and dry. The place is freezing cold. Rusty-colored dust is floating in the air. You make one step, then another. It's hard to move because of the thick layer of dust your feet are sinking into. You're on Mars, and you've come here after hearing some absolutely incredible news. These days, the so-called Red Planet indeed looks dry and dusty. But scientists think that this world might have been very different a long, long time ago. They have found some evidence of a huge ocean that could have existed on the surface of Mars about 3.5 billion years ago. And this ocean probably covered hundreds of thousands of square miles. It all started with numerous satellite images of the surface of the Red Planet. They were snapped at different angles. As a result, researchers managed to construct a relief map of the area. They charted out more than 4,000 miles of specific formations that had most likely been carved by rivers. Those formations could also be channels, once carved out on the sea floor. Scientists used the data gathered by the Mars Reconnaissance Orbiter in 2007. They analyzed the thickness of the ridges and their angles and locations. Their main goal was to explore the topographical depression called Aeolus Dorsa. It turned out that all those years ago, this part of the Red Planet had been undergoing a series of constant changes. They could have been caused by the rapid movement of rocks, pulled around by currents and rivers, as well as noticeable increases in sea level. Researchers also noticed a pretty clear boundary that separated the southern highlands of Mars, elevated and highly cratered, from the smooth lowlands of the planet. It looked very similar to a shoreline left by a ginormous ocean. This all likely means that in ancient times, there indeed was an ocean on the surface of Mars, and a large one at that. What's even more exciting is that the existence of such an ocean might mean the existence of life. This discovery can tell scientists a lot about the ancient climate on the Red Planet, as well as its evolution. We now know there had to be a period on Mars when the planet was quite warm, and its atmosphere was thick enough to keep so much liquid water. What's even more incredible, the climate in the northern hemisphere of Mars 3 billion years ago could have resembled the one we have on Earth nowadays. But then, where is this ocean now? What happened to it? Perhaps the climate of the Red Planet was becoming cooler, and the surface of the ocean froze. There's a theory claiming that these days, the ocean remains in its frozen state deep under a layer of rock, debris, and dust under a northern plain called Vasticus Borealis. Or the ocean's waters could have been lost to the atmosphere, and eventually space through the process of atmospheric sputtering. During this process, atoms get knocked away from the atmosphere after colliding with high-energy particles coming from the sun. Anyway, the theory of an ocean that once covered a substantial part of Mars's northern hemisphere hasn't been confirmed yet. Scientists are still arguing about its existence. As for now, Mars is a very cold world with an average temperature of -80 degrees Fahrenheit. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. The ocean that might have existed on Mars isn't the only awesome thing about this planet. Let's speak about those sandstorms raging on the Red Planet. In movies, they're depicted as incredibly powerful forces of nature, destroying astronauts' camps and tearing their spaceships into pieces. But how much of it is true? Mars is indeed infamous for producing dust storms so massive they can be seen by telescopes on Earth. They sometimes cover continent-sized areas and can last for weeks at a time. But besides them, there are much rarer storms that occur once in 3 Mars years, which is about 5.5 Earth years. Such storms are larger and much more intense than regular ones. They encircle the entire planet. That's why scientists call them global dust storms. At the same time, it's unlikely that even a global dust storm could cause serious harm to astronauts or their equipment. Even though Martian storms are massive, the wind speed reaches 60 miles per hour tops. That's less than half the speed of most hurricane-force winds on Earth. Plus, this comparison of wind speeds can be kind of misleading. The atmosphere on Mars is just 1% or so as dense as the atmosphere on our planet. It means that the wind there needs to blow much faster to cause any damage, or even fly a kite. Now let's move to the next amazing phenomenon spotted on the Red Planet. When you look at it from a distance, it looks like an eye. There are even some winding channels that look like veins running through the eyeball. But the closer you get, the less the formation looks like an actual eye. It's actually a giant crater, almost 19 miles in diameter. Around the crater, which looks as if it has a pupil, there are other, even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once, water filled the ginormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Your next destination is Valles Marineris. That's an enormous canyon, or rather, a canyon system, that runs along Mars's equator. It stretches for more than 2,500 miles. It's also 4 times as deep as the famous Grand Canyon on Earth. The thing is so huge, it could span the entire continental United States, from the Pacific to the Atlantic Ocean. Most scientists think that Valles Marineris is a huge tectonic crack in the crust of the Red Planet. It could have formed when the planet was cooling down in the distant past. Another breathtaking sight on Mars is the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which means it's almost the same size as the state of Arizona. The mountain is also 16 miles high and rimmed by incredibly tall cliffs. To imagine the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, around 2.6 miles high and 75 miles across, which actually sounds pretty impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. Scientists have been wondering for quite some time why this volcano is so large. It might be the result of lower surface gravity and higher eruption rates. Or the reason may be the red planet's crust, which is very different from Earth's. On our planet, the crust is made up of 15 to 20 moving tectonic plates. As plates move over hotspots that produce lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. Now, if you visited Mars and decided to go on an evening stroll, you'd witness a strange phenomenon. It occurs on the red planet after sunset, when temperatures fall below -80 degrees Fahrenheit. A bizarre, mysterious glow spreads across the Martian sky. Unfortunately, without special equipment, you wouldn't be able to observe this soft glow. Visible only in ultraviolet light, this night glow is the result of chemical reactions that occur dozens of miles above the surface of the red planet.
We've been dreaming about life on Mars for a long time. Not only about growing potatoes there in the future, but also about all the potatoes that could have been there in the past. Has there ever been life on Mars? Recently, scientists have found something that could be evidence of that. Let's find out what happened. Mars is the fourth planet from the Sun. A human hasn't set foot on Mars yet, but robots have set their wheels. The first spacecraft that visited the Red Planet were NASA Viking landers. They flew there back in 1976 and sent us a lot of interesting data. Back then, we didn't know anything about Mars. To us, it looked like a cold, lifeless desert. But since we're so similar, scientists began to wonder, has it always been like this? Or is it possible that once Mars used to be thriving and full of life? And in 2022, NASA's Mars rover Perseverance found something that could shed a light on this mystery. But first of all, what is Perseverance? Scientists have suggested that if there was life on Mars once, it's unlikely that it could simply disappear without a trace. It must have left some traces, perhaps underground, where they would be protected from radioactive solar tantrums and other nastiness. So we need to check the rocks. It's important to note that we aren't looking for life on Mars right now. There most likely isn't any. Instead, we want to look into the distant past of our twin planet. We're talking billions of years ago, when Mars could have been warm, green, and far from lifeless. In other words, we have to find dead microbes and various chemical compounds similar to ones on the Earth. This is the mission of our main character, Perseverance. It arrived on Mars in February of 2021. The spacecraft landed on the bottom of the 30-mile-wide Jezero crater, and after landing, it scooted over to the west, to the place that prompted scientists to choose Jezero for research. This place is a dried-up river delta, and this former river is already more than 3.5 billion years old. The Jezero crater itself was once a large lake. Yup, apparently there was life on Mars, and scientists have suggested that these places would be perfect as bodyguards of microbes. That's exactly what bacteria do on Earth. They hide, being still in the depths of lakes and ponds, so we could probably find traces there. The researchers believe that this particular lake has the highest scientific value in the entire mission. The highest chance to find rocks on which such bacteria could survive is here in Jezero. So Perseverance went to the Delta. The row wasn't easy, though. The rover missed a little and landed further than planned. As one famous movie said, "This little maneuver's going to cost us 51 years." Fortunately, Perseverance took only 1 year, and on the way, it was able to explore Jezero a little. The rover uses a complex built-in tool to explore the world. The tool is called Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or just SHERLOC. Boy, NASA sure loves its acronyms. As the device approached the Delta, the signal of organic molecules became stronger. Soon, these signals were everywhere, and besides, they were the brightest that the scientists have ever seen. What does it mean? Elementary, my dear Watson. You know, Sherlock. It's time to dig. Since July 2021, Perseverance has drilled and collected 4 thin cores of sedimentary rock. The total number of collected rocks at the moment is 12. This is the first time in history that we're collecting something like this on another planet. These 4 cores were found on 2 rocks called Skinner Ridge and Wildcat Ridge. The first pair of cores, the ones from the Skinner Ridge, don't seem very interesting at first glance. They're quite close to what we can find in many places on Earth. However, if we look at them closer, we'll see that they're dotted with round grains of some dark material. These dark grains could have once been deposited on them by an ancient river, the same one that flowed into Jezero. It's possible that the river brought them from places hundreds of miles away from Jezero, and that's pretty cool. If we study these cores, we'll be able to learn even more about the far corners of Mars. Well, there are no corners on it, but you get the idea. Then, in April 2022, Perseverance did arrive at the Delta, and then scientists finally found what they were looking for. The discovery, to put it mildly, excited them. They found 2 more cores, which held organic substances. This pair was taken from the Wildcat Ridge. It's found very close to the Skinner Ridge, but the 2 rocks are quite different from each other. These samples are lighter in color and more uniform. Most likely, they're mudstone, an unusual rock similar to clay, but harder and unable to absorb water. They're also finer grained than the cores of the Skinner Ridge. Why does it matter? Because the finer the grains in the stone, the more likely it is that there may be some traces of a past life in it. On Earth, fine-grained stones most often lie on the bottoms of ponds and in similar places. There, they can preserve the remains of dead organisms and similar stuff for years. And this is exactly what we found on them. Additionally, according to scientists, there was more organic matter in these 2 cores than in any other place studied by Perseverance so far. It probably accumulated there while the lake was gradually evaporating billions of years ago. So, there really was life on Mars? Well, let's slow down a little. Organic substances are molecules holding carbon. And yes, on Earth, they're most often associated with life, but not always. Sometimes they can form as a result of other things. Therefore, we cannot say for sure whether there was life on Mars. We don't know if these molecules really remain from some Martian microbes, or if they're the result of some other things. But the discovery is still very significant. We have to literally keep digging this way. To learn more about this organic matter, scientists need to collect a couple more samples of fine-grained rock. It would also be great to study the material lying around these former reservoirs. Perseverance has already moved to another area, to a place with a beautiful name, Enchanted Lake. Now it needs to look for similar things there. It will also continue to study Lake Jezero. Eventually, Perseverance will climb to the top of the delta and then continue exploring ancient sites outside the crater. Sometime before the end of 2022, Perseverance will probably have 6 or more samples of the Martian cores. Unfortunately, its tools, though complex, are quite limited. This data alone won't be enough for us to get a complete picture. Therefore, NASA plans to send other spacecraft to Jezero in the coming years. Together with the European Space Agency, they're working on the next robotic mission, known as the Mars Sample Return. The name speaks for itself. These devices will arrive and take away all the test tubes from the old Prospector Perseverance. After that, These samples will be delivered to Earth, though not by Amazon Prime, and then scientists will be able to analyze them in advanced laboratories. However, all this will take a really long time. The launch of this mission is scheduled for 2027-2028, and the spacecrafts won't be able to return until 2033. But if everything goes well, it will be the first samples in history delivered to Earth from Mars. In other words, there's still enough space for research, literally. And yes, we don't yet know the true meaning of these finds. But that's why the entire mission was created, right? And who knows? Maybe in a few years we'll finally find out the truth about what happened on Mars billions of years ago. Ooh, check out the Martian! Made you look. What a nice cosmic family. Meet Mars. I bet you've met him before. These two little guys are Phobos and Deimos, Mars's small moons. But it seems like Mars isn't treating the little ones the right way. Phobos and Deimos are believed to be captured asteroids. However, Phobos is gradually moving closer to Mars due to gravity, and it is predicted that it will eventually be destroyed by the planet's gravity within the next 35 million years. I won't be around then. So, I imagine this will result in a ring of debris around Mars, similar to Saturn's rings. However, this process is a natural phenomenon and not an act of destruction by Mars. Apparently, Phobos is getting ripped apart by the crazy gravitational forces of the Red Planet. But wait, there's more! Phobos has these crazy parallel grooves all over its surface. We used to think that they were from an asteroid crash, but now scientists think they're actually from Mars's intense gravity pulling the moon apart. Talk about a rough ride! Scientists have this wild idea that when a little guy like Phobos gets too close to a big guy like Mars, it starts to stretch out towards it. They call it the tidal force. Phobos is predicted to get stretched out so much that it'll actually break apart. Crazy, right? And the debris from the moon will form a tiny ring around Mars, just like Saturn's rings. Now, some people thought that Phobos' tiger stripes were caused by tidal forces before, but that theory got shut down because the moon is just too darn fluffy. But now, these genius researchers ran some computer simulations and found out that maybe there's a hard shell underneath all that fluff that could create grooves on the surface. But don't worry. At the rate Phobos is going, it's going to crash into Mars in about 40 million years. But if tidal forces are already tearing it apart, it might not even last that long. However, we'll still have the chance to learn more about Phobos. NASA just picked 10 rockstar researchers from all over the U.S. to join the science working team for JAXA's Martian Moons Exploration, or just MMX mission. As NASA-supported participating scientists, they'll be helping JAXA explore the two Martian moons, Phobos and Deimos. And get this, they're even planning to land on Phobos and grab a surface sample. The mission is set to launch in 2024, and we'll get our hands on that sample in 2029. 7 of the lucky researchers will be using the MMX flight instruments to conduct their research. Phobos is a real oddball. It's only 17 miles wide and orbits Mars at a distance of 3,728 miles, to be precise. Now that's way closer than Earth's moon, which takes a whole 27 days to orbit us. But Phobos is in a death spiral toward Mars and is slowly falling towards the planet's surface at a rate of 6 feet every 100 years. But there must be a reason why Mars is acting that nastily, right? What if it's all just because of plain vengeance? Well, okay, picture this. Mars is minding its own business, being all hot and watery like a young Earth. It's got a sweet magnetic field that's protecting it from cosmic radiation and keeping its atmosphere nice and thick. Hey, life is good. But then, at least 20 asteroids, each the size of a small country, come crashing down on Mars like a giant game of cosmic whack-a-mole. One of them even leaves a crater that's almost 2,000 miles wide. Now imagine how Mars must feel with 2 asteroids being its moons after what other asteroids did to the Red Planet. All these impacts are like a massive punch to Mars's gut, and its already weak magnetic field is knocked out cold. The core gets all overheated and can't circulate properly, which means no more magnetic field to protect the planet. It's like as if you were wearing nothing at the depth of the Mariana Trench. If it were possible, you'd be defenseless and chilly. It's basically what happened to Mars. So now, poor Mars is out there in the cold, unprotected from all those nasty cosmic rays. It's like going outside without sunscreen, not a good idea. But at least we can learn from Mars's mistakes and make sure Earth doesn't have the same fate. Maybe we should start investing in some asteroid insurance. But trust me, the Red Planet isn't mean at all. It's actually pretty friendly. While Mars may seem to be pretty tough for Phobos, there's something that might be thriving with Mars's help. So get this, a team of scientists found a way to grow rice on Mars. Yep, you heard me right. They used MMS, not the outdated way to send pictures, but a special soil called Mojave Mars Simulant. It's supposed to mimic Martian soil. And here's the catch, Martian soil has these nasty percolate salts that can be toxic for plants. So the team grew 3 types of rice, 1 normal and 2 gene-edited with mutations that make them better at handling stress like drought or salinity. And guess what? The mutant strains were able to root in soil with 1 gram of percolate per kilometer. Take that, Martian soil. But hold up. The rice grown in the MMS didn't turn out as great as the ones grown in regular potting soil. So the team decided to mix a quarter of the potting soil with the Martian simulant, and looky there, the plants started developing better. Now these scientists aren't just thinking about feeding Martians. They also want to see if their findings can help grow crops in places on Earth with high salinity. And get this, the whole project started when 2 researchers met for coffee and decided to try growing plants together. Well, isn't that nice? I suspect you're about to say, hey, but if you want to grow rice on Mars, you'll have to ship insane amounts of water from Earth, and it's not easy to quench this plant's thirst. You're right. You need about 449 gallons of water to only grow a pound of rice. But guess what? Scientists made a groundbreaking announcement at the Lunar and Planetary Science Conference in Texas. They found a relic glacier near Mars's equator. That's right, water ice on Mars, even near the equator. This is huge news, and could mean there's even more ice just below the surface. It's not just any glacier, it's a relic glacier that's estimated to be 3.5 miles long and up to 2.5 miles wide. It's like the size of a small town. It's got all the features of a glacier, including crevasse fields and moraine bands. But get this, it's not actually ice. It's a salt deposit that formed on top of the glacier while preserving its shape. So, how did this salt deposit form? Well, it turns out that volcanic materials blanketing the region might have something to do with it. When these materials come into contact with water ice, sulfate salts may form and build up into a hardened, crusty layer. Over time, erosion removed the volcanic materials, exposing the sulfates and revealing the glacier's unique features. This glacier is young, likely from the Amazonian geologic period. That means that Mars has had surface ice in recent times. Who knows what other icy secrets Mars is hiding? But hold your horses, there's still more research to be done. Scientists need to figure out if there's still water ice preserved underneath the salt deposit, or if it has disappeared entirely. And if there is still water ice at shallow depths near the equator, that could have major implications for human exploration. Imagine being able to extract water from the ground at a warmer location. That would be a game changer. So let's see what else these scientists uncover about our favorite red neighbor. Maybe someday we'll even get to visit that salt glacier statue in person. See you next time.
How many people do we need to create a new civilization? And not on Earth, but on Mars, and in limited conditions. And if we create this colony and send them off, what problems will they face? How can they survive that far away from home without any support? A recent scientific study sheds light on these questions, so let's take a look at it. Alright, so you want to colonize Mars, right? Well, it's not an easy task. Mars is the 4th most distant planet from the Sun and the 7th largest in the solar system. This lonely red guy is very similar to our Earth. Moreover, before it became a boundless desert, it could well have even looked like Earth now. Millions of years ago, there was water, oceans, plants, and who knows, maybe even life. It would be nice to put all these cool things back there. No wonder we've been talking about colonization of this planet for a very long time. Now, SpaceX claims that their proposed interplanetary spacecraft could deliver 100 people to Mars. The owner of the company, billionaire Elon Musk, talked about creating a fleet that could provide a constant flow of resources to Mars. But how realistic are all these fantasies? Actually, not very much. Before sending people to Mars, we need to solve a number of issues. For example, the incredible radiation exposure, toxic soil, low gravity, low temperatures, and all sorts of other nasty things. And this is just the beginning. It will take at least a couple of decades to create a vehicle that can actually successfully land on Mars and return back. But let's do a thought experiment and imagine that we finally decided to colonize Mars. How will things turn out? Recently, scientists published a new study on this topic. This study is called Minimum Number of Settlers for Survival on Another Planet. The author is Jean-Marc Salati, professor at the National Polytechnic Institute of Bordeaux in France. His article was published in the Scientific Reports journal. As you might have guessed, the study was trying to find out how we could colonize another planet. How many resources do we need? How should this colony live? What kind of work should they do? And how long will it take? And, of course, exactly how many people do we need for all of this? Let's try to answer that. Now, imagine that we've moved into a wonderful future. Well, not really. A terrible future, actually. In his study, Salati suggested that life on Earth was threatened by some catastrophic event, so the only way for humanity to survive is to go to Mars or some other planet. In this imaginary scenario, unfortunately, the supply delivery from Earth was interrupted, or even gone. Now, the colony has to support itself somehow. Well, here's where we already stumble upon a bunch of problems. For example, we're not sure how well the people in the colony will work together.
Hey!
Will they communicate with each other like normal human beings? Will they share their time and resources as they should? Humans are constantly ruining things for other humans. I can even bet that it was their fault we had to flee to Mars. But even if we forget about that, how about organizational issues? What equipment do we have? What will we use to extract resources? What skills would we need? You know what? Who cares? In our case, these things don't matter. All that we know is that the colony doesn't have a lot of initial resources and equipment, and the human factor is absolutely unpredictable. So the chances of survival are pretty low, but we need to survive somehow. In this case, Salati describes 2 things that will have a huge impact on our survival. These things are essentially variables in a mathematical equation. The first one is the availability of local resources. Basically, it means water, oxygen, and all sorts of useful chemical elements. These resources should be somehow mined and easy to use. Fortunately, we're not starting from scratch. We already know a lot about Mars. What resources are there? How can they be used for life support, agriculture, and industrial production? The colony is lucky because all this has been studied at various seminars and published in reports and books over the past years. Thanks to this, we know what will be available to our colony. For example, we know that gases could be extracted from the atmosphere and minerals from the soil. On Mars, we could provide such things as iron, glass, and even organic compounds. The most important problem here is the service life of the equipment that our new Martians start with. They'll have to get as many materials as possible before the tools break. Keeping them in good condition will be almost the most important task. The second thing is the production capacity, or the speed of work. We have a specific list of things we need to do. Make some tools, for example. and all this must be produced in sufficient quantities before the literal deadlines. Salati says that the most important thing here will be the so-called sharing factor. Imagine one person trying to survive on Mars. They would have to do all the tasks on their own. They would need to find or build their own system for supplying drinking water, oxygen, and electricity generation. We've already seen how this played out in the movie The Martian. This task wasn't easy at all. There's always not enough time, and all of this is just too much for one person to handle. Unless you're Matt Damon, of course. So, surprisingly, we need a fairly large colony. This significantly distributes the burden. Each person spends less effort, gets tired less, and, as a result, the efficiency and speed of work grow. This is where the sharing factor comes into play. Now we need to calculate this number. If we want, for example, to build something, how many people do we need to do this quickly and efficiently? How can we optimize the work as much as possible? Well, it depends on the needs of these people, on available resources, random things like weather, and so on. But in general, this number can be estimated and calculated using some mathematical functions. Salati tells in more detail about these functions in his article. You can read it yourself if you're interested, but in general, he describes 5 areas that need to be taken into account when calculating this number. These areas are ecosystem management, energy production, industry, buildings, and the human factor. The human factor includes such things as the upbringing and education of children, sports, games, music, and so on. In the end, it all comes down to 2 things: how much time we have and how well the people in the colony will work with each other. So, what was the result of all these calculations? In the end, Salati found out that we would need at least 110 people to successfully survive on Mars. This is the minimal number needed to create a self-sufficient civilization. And it will be better if we don't take too many people with us. The more people we take on the spacecraft, the more difficult it will be to predict the results. After all, as we've already said, humans are always ruining things for other humans. So it's better to stick with about 110 people. Of course, this is a rough estimate, and there are a bunch of different assumptions and uncertainties, but even this number is already very useful. Now the scientists know how many people is a minimum for colonization of another planet. Colonizing other planets is a very complex issue, and it will take us a very long time to resolve it. It's very unlikely that we'll fly to Mars in the near future. This task may take several decades, or even a century. Therefore, the best solution would be to try our best to save Earth until we can begin to conquer other planets.
It's staring at you, and you're staring at it. A giant eye that seems to be pulling you into an abyss. You're hovering over it in your space copter. But however scared you might be, you still need to do your job. So you send your copter down to the surface of the red planet. Right, that's where you are, on Mars. But first things first, you take a moment to remember everything you know about the 4th planet from the Sun. It's the last of the inner planets. Those are the planets that lie within the asteroid belt. They're also called terrestrial, since they're made up of rocks and metals. The atmosphere of Mars is much thinner than Earth's. It contains 95% carbon dioxide and a mere 1% of oxygen. In other words, don't even think about pulling off your helmet. Anyway, there's no time to waste. You land on the surface of the planet and find yourself in a brownish-red world. That's a good thing you're wearing a spacesuit. This place is freezing cold. The thermometer sewn into the sleeve of your suit shows minus 80 degrees Fahrenheit. Time to take your first step on the Martian surface. The planet looks quite colorful, and the hue of a particular area depends on the minerals that make up the soil. The ground under your feet is covered in fine dust. It looks like rust. The same orange dust is in the air. Good thing you have your own supply of oxygen and don't need to breathe Martian air. The layer of this dust covering the surface of Mars can be from 6 to 40 feet thick. You hope you'll avoid getting swallowed by some Martian quicksand. You start walking, feeling very light. Mars is just 15% of our planet's volume and a mere 11% of Earth's mass. It means that gravity here is much weaker. Its pull is 38% as strong as the pull of gravity on the surface of Earth. You jump up and down and then try to run several hundred feet. Ha! You haven't even broken a sweat. What makes it harder for you to explore the place on foot is that the planet's surface is rocky, covered with craters and volcanoes, old dry lake beds, and canyons. You see something huge towering on the horizon, but you try to suppress your curiosity. You'll have enough time to figure out what it is later. Suddenly, a massive cloud appears in the distance. It looks as if a huge herd of horses is approaching you. In reality, you better get back into your copter and fly away as fast as you can. That's one of Mars's infamous dust storms. They mostly occur during the summer in the southern hemisphere of the Red Planet. They can sometimes cover the entire planet, and you see the largest ones from Earth. You hop into your copter and set a course for the eye that scared you so much. Winding channels that look like veins run through the eyeball. But the closer you get, the less it looks like an actual eye. Soon you realize it's a crater. It's giant, almost 19 miles across. Around the crater, which looks as if it has a pupil, there are other even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once there was Martian water in the enormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Now, remember that towering something on the horizon? It's time to go and explore it. When you come close, you realize it's the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which is almost the same size as the state of Arizona. You tilt your head. Wow! The mountain is 16 miles high. It's also rimmed by 4-mile-high cliffs. To picture the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, towering around 2.5 miles above sea level and stretching 75 miles across. Sounds impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. But why is this volcano so large? It might be the result of lower surface gravity and higher eruption rates. Or the reason might be the red planet's crust, which is very different from Earth's. It's static. You see, on our planet, the crust is made of 15 to 20 moving tectonic plates. As plates move over hotspots producing lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. So, how about getting closer to the enormous mountain? But once you step out of your copter on Martian soil, the ground under your feet starts shaking. Well, that's a Marsquake. But how can it happen if Mars doesn't have any actively shifting tectonic plates? Specialists from NASA are sure Marsquakes occur when energy inside the planet gets suddenly released. It leads to rock fractures and cracks in the planet's crust. Another powerful jolt, and one of such cracks opens right next to you. You fall to the ground, afraid to move, but soon everything calms down. You wait for a couple of minutes, just to be sure, and get up. Oh look! Here's a perfect opportunity to explore the insides of the red planet. The crack is large enough to send a special research robot. The planet's crust is thin and consists of volcanic basalt rock. The mantle that surrounds the core of the planet is made up of thick silicates, oxygen, and some minerals. You can probably compare it with soft, rocky toothpaste. Mars's mantle is also much thinner than Earth's. It's just 800 to 1100 miles thick. As for the planet's core, it's made mostly of iron, nickel, and sulfur and is between 900 and 1200 miles wide. This core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. Unfortunately, your drone is now lost in the depths of the red planet. You leave it there and continue your exploration. Your next destination is Valles Marineris. It sounds more like an Italian red sauce, but it's actually an enormous canyon. or rather a canyon system, that runs along Mars's equator. It's as awe-inspiring as Olympus Mons, more than 2,600 miles long and over 4 miles deep. The thing is so huge, it could span the entire continental United States from the Pacific to the Atlantic Ocean. Now let's make another comparison. One of the most famous canyons on Earth is the Grand Canyon in Arizona, but it's 10 times shorter and around 4 times less deep than this canyon on Mars. Some scientists think that Valles Marineris is the edge of an enormous tectonic plate. It moves so slowly that almost nothing has happened in that region over millions of years, and the movement of this plate probably began 3.5 billion years ago. Anyway, the only thing left on your today's to-do list is to visit Mars's moons. They're among the tiniest in the solar system. Phobos is the largest of the two. It orbits a mere 3,700 miles above the surface of Mars. There's no other known moon that travels closer to its mother planet. It whips around the red planet 3 times a day, while the second moon, Deimos, needs 30 hours to complete one orbit. Phobos is getting closer and closer to Mars, about 6 feet each 100 years. Within the next 50 million years, it'll either crash into the planet or break apart and form a ring. Happy but tired, you return to your spaceship. Tomorrow, you'll continue exploring the magnificent red planet, and who knows what discoveries are awaiting you. Have we found another civilization? Is that a door to someone's home on another planet? Can we peek through the windows? After all, it was NASA's Curiosity rover that sent this image to Earth, and right now, this rover is exploring the surface of Mars. Unfortunately, astronomers were fast to disappoint us. They claimed that it was just a natural part of the Martian landscape. There are several clues that made them think it wasn't a real door. For example, it's tiny, a mere 3 feet high. But it might simply mean the Martians aren't that tall, you may object. But scientists keep insisting that what looks like a door is actually an opening in a rock created by natural forces, like winds and erosion. The thing is, if you look at the rock attentively, you may notice strata, the layers of silt that stand out because they're harder than the surrounding material. These strata dip here on the left and a bit higher on the right. They likely appeared around 4 billion years ago in a river or a wind-blown dune. Since the strata became visible, powerful Martian winds have eroded them even more, and now you can see that they disappear inside the door. And look at this. See those cracks? Yeah, those. That's how rocks weather on the red planet. This small cave probably formed when several fractures crossed the strata. A pretty large boulder might have fallen out under its own weight, and this created the door-shaped opening. Now, this theory is quite plausible, because even though the gravity on Mars isn't as strong as on Earth, it's still strong enough to do it. Besides, see that rock to the right of the opening? It has a suspiciously smooth vertical edge. It must be the culprit. It probably fell out not so long ago, and Martian winds haven't got rid of it yet. And winds on Mars can be exceptionally powerful. This planet is infamous for its intense dust storms. Sometimes they kick up so much dust that you can see it through a telescope on Earth. Such storms occur every year and cover continent-sized areas. They also last for weeks at a time. But besides these annual storms, there are even larger storms that happen much more rarely, but they're more powerful and way more intense. Those are called global dust storms because they encircle the entire planet. But even if you got caught in the most severe storm on Mars, it wouldn't be as terrible as you might think. The wind speed on the worst Martian storms reaches 60 miles an hour tops. Hurricane-force winds on our planet can be twice that speed. You should also keep in mind that the atmosphere on the red planet is 1% as dense as the atmosphere on Earth. That's why, if you decided to fly a kite on Mars, you'd need the wind to be much faster than on Earth. Otherwise, you wouldn't even be able to get the kite in the air. In other words, even though it's quite windy on Mars, it doesn't feel as intense as on our home planet. Oh, by the way, you might have noticed I keep calling Mars the red planet. Why? Look, our neighbor is covered in dust, soil, and rock that is rich in iron oxide. That's what gives the surface of the planet its trademark red hue. And look, there's the trademark. Nah, just kidding. Mars is the 4th planet from the Sun. Not so far away from the star, you might say, and still, it's a cold and deserted world. The average temperature on its surface is minus 81 degrees Fahrenheit. But if you ever visit one of its poles during the wintertime, bring a lot of warm clothing, because the temperatures are likely to drop to minus 220 degrees there. In the summer, though, you might feel very comfortable in some regions. There, the temperatures can rise to 70 degrees, not very different from what we're used to. Mars is one of the most explored space bodies in the solar system. At the moment, NASA has 2 rovers roaming the red landscapes, Curiosity and Perseverance. There's also one lander called InSight and helicopter Ingenuity, nicknamed Ginny. Perseverance is the most advanced and largest rover ever sent to another world. The journey to the red planet took 203 days, and Ginny traveled to Mars attached to the belly of Perseverance. Sounds cozy. And now, I'm going to tell you something really curious. Let's say you're a Babylonian who lived around 5,000 years ago. Babylonia was an empire in ancient Mesopotamia. Just think back to 6th grade. Anyway, your neighbor comes up to you and says, "What day is it today?" And what do you answer? "It's Mars Day." Wait, what? When the ancient Babylonians created the week, they decided to divide it into 7 parts. Each day got named after some space body, like the Moon, the Sun, Venus, and so on. Mars Day was on Tuesday. The Babylonians believed that each of these space objects influenced their lives on the day named after it. And since Mars was red in color, they associated it with aggression. That's why on Tuesdays, they had special ceremonies to avoid the influence of the unfriendly planet. Indeed, Mars might seem unfriendly to a tired traveler. Its atmosphere is very thin. Its volume is a near 1% of the atmosphere on Earth. In other words, there's 99% less air to breathe on the red planet. Mars's atmosphere is mostly made up of carbon dioxide. At such high concentrations, it's toxic for us humans. And if you were looking for some oxygen to breathe on Mars, you'd come away empty-handed. There's only 0.1% of oxygen in the air on the red planet. That's definitely not enough for you to survive there. At the moment, Mars has 2 moons, Deimos and Phobos. Astronomers think they may be asteroids once caught in the gravitational field of the planet. The moons are shaped like potatoes. That's because their mass is too little for gravity to give them a spherical form. Potatoes, eh? Maybe they should be renamed mashed and au gratin. One day, Mars will get a ring of its own. It might happen in the next 20 to 40 million years. Will Brightside be there? Stay tuned. Mars's gravitational forces will tear apart the planet's largest moon, Phobos. Hey, it really will get mashed. Some chunks of the former moon will crash into Mars, and others will break apart and create the ring around the planet. This ring might exist for at least 100 million years. The surface of Mars is cut by a huge canyon system known as Valles Marineris. Sounds like a pasta sauce. If it were on Earth, it'd stretch all the way from New York to California, over 3,000 miles. At its widest part, the largest canyon on Mars is 200 miles, and it reaches 4 miles at its deepest point. If you still have difficulties imagining the sheer size of this natural phenomenon, here you go. Valles Marineris is 10 times the size of the Grand Canyon on Earth. Now, since we're on the subject of gigantic things, let's talk about Olympus Mons. This is the largest volcano in the solar system, and it's on Mars too. It's 3 times as tall as Mount Everest on our planet, and that's the tallest mountain above sea level. And the base of Olympus Mons is as large as the state of New Mexico. Now, scientists think there could have been water on Mars in the past. What made them think so? They found lots of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that could only form in liquid water. Mars might even have experienced terrible floods 3.5 billion years ago. These days, there's still some water on the red planet, but Mars's atmosphere is too thin for this water to stay in its liquid form on the surface. Now, it only exists in the form of water ice. You can find it just under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes, salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. So, as a vacation spot, I think I'll pass.